Okay guys, so what we have here is the 2007 5A. A smooth sphere P of mass 2 kilograms, moving with speed 9 meters per second, collides directly with a smooth sphere Q of mass 3 kilograms, moving in the same direction with speed 4. Okay, so that's what we're looking at here, and then before and after picture. This makes things that bit easier. Okay, so 2 kilograms, 3 kilograms, 3 kilograms, 2 kilograms before and after. Okay, now they're only moving in one direction, so that's going speed 9. This one's going speed 4 in the same direction, and then after the collision, V1 and V2, and then coefficient of restitution is E. Don't know anything about it. Find in terms of E the speed of each sphere after the collision. Show that the magnitude of the momentum transferred. Anybody remember a different word for that? Well done. Somebody's done a small bit of revision there. So it's the impulse, the change in momentum. Okay. Transfer from one sphere to the other is 6 bracket 1 plus E. The magnitude is another key word there. Magnitude. What does magnitude mean? If I had the minus version of that, is it still the same answer? Magnitude means take it all as positive. Or sorry, it'd be it could actually be that one there. And you just get, it's like the modulus. If I had minus 28, it's still the same thing as plus 28. So it doesn't matter if you get the minus or plus version of that. Once you have one or the other, you got it right. Just do correction at the end, okay? So let's start off with using our system. You can see that you don't even have to do much interpretation of the question. It's just actually just immediately go to PCM and NEL every time. Okay, so just shrink that. There we go. So PCM, M1U1. So 2 kilograms times 9. We'll write it down. M1U1 plus M2U2 equals M1V1 plus M2V2. Okay, 2 times 9 plus 3 times 4 ends up to be 2V1 plus 3V2. 2V1 plus 3V2 ends up to be 30. NEL. V1 minus V2 equals minus E bracket U1 minus U2. Okay, V1 minus V2 ends up to be minus E bracket 9 minus 4. V1 minus V2 ends up to be minus 5E. I need the speed of each sphere, so I'm going to do them both. I'm going to multiply this by 2 while I'm here, or sorry, 3. So I'm going to get 3V1 minus 3V2 equals minus 15E. Then I'm going to get 2V1 plus 3V2 equals 30 underneath. I'm going to get 5V1 equals 30 minus 15E. V1 equals 6 minus 3E. Okay, V2. I could do that by substitution this time because it's fairly easy. There's no fractions, so I'm going to do V1 equals V2 minus 5E. So that means it's 6 minus 3E. Oh, sorry, is it plus or minus 5E? Huh. Appears I made a mistake on this one back in the day. Sorry, just keep. Okay. So 6 minus 3E is V1 minus the extra 5E, and that'll get me 6. Oh, sorry, V2 is. Now I'm confusing myself. Excuse me. V2 goes to the right, the 5E goes to the left, so I'm going to get V1 plus 5E equals V2. I was right. So I'm getting 6 minus 3E plus 5E equals V2. Therefore, it's going to be 6 plus 2E equals V2. Everybody alright with that? Now, the impulse, guys, you can take either particle. And what impulse is, or change of momentum is, it's mv1 minus mv2. Okay? And it doesn't matter if you do mv1 minus mv2. Why does that not matter? What's the modulus of 9 minus 5 compared to the modulus of 5 minus 9? Same thing, isn't it? It's a change of momentum. The momentum is it getting bigger or smaller anyway? Just as a matter of interest. When you collide with something, for the most part, one of you is gaining momentum and one of you is losing. If I use the particle that's going 9 meters per second, is that gaining or losing? Gotta lose, because it's this faster particle. And this one, gotta gain. Okay. So here, take the take whichever one. We'll take the 2 kilogram particle. Okay. So what I'm going to say is I equals mv1. It used to be going. Technically speaking, it's not the v1 and v2 I got. It's just the speed before and after of the 2 kilogram particle. So it's going to be 2 times 9 minus 2 times, what did I say its speed was? 6 minus 3a. Then it's going to be modulus of 18 minus 12 plus 6e. And the modulus of 6e plus 6. Yeah, take that. Or the modulus of 6 into 1 plus e. Same thing. Yes? Sorry? Oh, sorry. What I meant there was see V1 and V2. What I strictly said was it's actually not V1 and V2 as we have it in our question. It's actually you take one particle. I took the 2 kilogram particle. It's its speed before, it's its momentum before minus its momentum afterwards, because it's the change of momentum. So I'm only going to use speeds belonging to one particle. Okay, so that's why it's 2 times 9 minus 2 times 6 minus 3e. On a different note, if I used a 3 kilogram particle, okay, I could say that it's 3 times, what was it, 3 times 4, yeah, minus 3 times, what was its speed after impact, 6 plus 2e. And I could do the same thing here, and I get 12 minus 18 minus 6e. And that was what I was talking about, wasn't it? The opposite one, which is minus 6 minus 6e. But because it's the change of momentum, it's going to be 6 plus 6e, which is 6 into 1 plus e. Doesn't matter which one you do, once you use its speed before and its speed afterwards. We have here is smooth sphere A of mass 4 kilograms moving with a speed u collides with a stationary smooth sphere of B of mass 8 kilograms. The direction of motion of A before impact makes an angle alpha with the line of centers after impact. The coefficient of restitution of spheres is the E value is 1/2. Find in terms of u and alpha the speed of each sphere after the collision. So what I'm going to do is I'm going to extend this line up through here. Got to use alternate angles, or sorry, opposite angles. And what I'm going to realize is that the speed of particle A is u cos alpha along this direction, and u sine alpha along that direction there. Everybody right with that? Now, time to do the before and after picture. 1, 2, and 3 and 4. Okay. So what we're going to have here is a stationary particle, the second one. Okay, 4 kilograms, 8 kilograms, 4 kilograms, and 8 kilograms. Change color. Okay, u cos alpha, u sine alpha. Straight away after impact, u sine alpha and V1. After impact, V2 and 0, and before impact, 0 in both directions. Everybody alright with that? Set up your PCM, your M1U1 plus your M2U2 equals M1V1 plus M2V2. Start plugging numbers, okay? So what we're going to get is 4U cos alpha plus 8 times 0 equals 4V1 plus 8V2. Divide both sides by 4. We'll get V1 plus 2V2 equals U cos alpha. Everybody alright with that? Okay. Next thing we're going to do is go for NEL. Just put that in a V square just so I know where it is. Okay, let's go for NEL. NEL is V1 minus V2 is minus E times U1 minus U2. Do I know the E value? It's a half, okay. So V1 minus V2 equals minus E, which is minus a half, into U cos alpha. U cos alpha minus 0. So we're going to get, I'm going to multiply both sides by 2. So we're going to get 2V1 minus 2V2 ends up to be minus U cos alpha. Is that right? Now, going to bring both formulas down here, and add them directly downwards. What do we know is about 3V1 is equal to 0. In fact, V1 is indeed 0. Alright. Now, what's V2? Is what we should be trying to figure out now. I'm going to multiply the top one by minus 2. Okay? So the top one's going to get multiplied by minus 2, so it's going to be minus 2V1 minus 4V2 equals minus 2U cos alpha. The bottom one, which is in green, remains unchanged. 2V1 minus 2V2 equals minus U cos alpha. 2 of them cancel. Minus 6V2 equals minus 3U cos alpha. V2 is going to be minus 3 divided by minus 6. U cos alpha all over 2. Everybody alright with that? Okay. So I have found the speed of each particle after collision. Find the angle through which the 4 kilogram sphere is deflected as a result of the collision. Okay, the 4 kilogram particle. So I want it was going angle alpha, and now it's going at a different angle. So if I just make a quick diagram here, angle alpha, new angle, reference with the x-axis. Angle alpha. We'll call angle beta the angle of deflection. If that's alright with you guys. Okay. Now, what do we know about angle beta this time? Phi is 0. So what does that mean? It's going straight up. It's a 90-degree angle. Okay, so that eliminates down things for us. So that's actually angle beta, and that's angle beta. Alpha plus beta equals 90. It wants me to keep things in terms of alpha, right? So beta equals 90 minus alpha, which we'll put in here. Everybody alright with that? So what is the angle of deflection, guys? Angle of deflection is 90 minus alpha. A much easier question than last time. Okay? So I actually won't need any of that again, so I'm just going to get rid of all this now. So that's it. Done and dusted. Now, last part. The loss in kinetic energy due to the collision. Loss in kinetic energy. So, loss in KE is KE before minus KE after. Okay, let's pick up some attempt marks with minimum effort. Let's write down Ke before. So what is kinetic energy before, guys? A half mv squared, or where v refers to the velocity, nothing specific to the question. Okay, so it's a half. What weight is our first particle again? 4 kilos. And it was going how fast? It was going with, now remember, you're talking about the magnitude, not the individual components. So you're talking about it being u, right? So a half 4u squared, which will get me 2u squared. Okay. Now, K after. Now what I could do with K after is this. It's going to be a half 4 times its speed squared plus a half, what's the weight of the other one? 8 times its speed squared. So let's have a look at the speed. We're going straight up, aren't we? So the speed of this particle is u sine alpha. In the event that we weren't going straight up, what would I have to do? If that wasn't 0, I'd have to do Pythagoras and find the hypotenuse, okay? But I don't have to this time. So u sine alpha squared. And then for the 8 kilogram particle, what's phi 2? U cos alpha all over 2. Okay. K after is going to be 2 u squared sine squared alpha. A half times that is 4. And then square that out. It's going to be u squared cos squared alpha all over 4 times 4. And that is going to be, what's it going to be? It's going to be 2u squared sine squared alpha plus u squared cos squared alpha. Anybody find a way how we might reduce that down a little bit? I can break this up into what? U squared sine squared alpha plus u squared sine squared alpha plus u squared cos squared alpha. And you see the way I can factorize the sine squared alpha and the cos squared alpha? What's that going to turn into? 1. So I just reduced it down a little bit more. So what I would have got is u squared sine squared alpha plus u squared. Okay. Did it a different way last time, but it's all the same. Now, that's K after, yeah? So Ke before minus Ke after. So that is 2u squared. 2u squared, which is here, take away the rest of it, which is minus u squared sine squared alpha. Oh, minus u squared. I'll say plus u squared. So we're going to get u squared minus u squared sine squared alpha. That should be an acceptable answer, right? But I have one last parting gift. What's 1 minus sine squared alpha? It's cos squared alpha. Because cos squared alpha plus sine squared alpha equals 1. Bring it over the other bring the sine squared alpha over the other side, so it's going to answer u squared. U squared cos squared alpha.